A trapezium-shaped table can seat 5 people. Amber uses the trapezium-shaped tables to form figures that follow a pattern to plan the number of people sitting around the table. The first 3 figures are shown below. So let's observe the diagram first. So if you look at figure 1, the question already says it's a trapezium-shaped table. So treat this as a trapezium. You don't have to look at it as 3 triangles. Okay, so at this point, the triangles is not really so important. More likely, we'll be focusing on the trapezium first. All right, so all these gray circles are the 5 people that are around the table. So looking at figure 2, notice that there are 2 trapeziums this time, because if I were to show you, this is first trapezium, and the second one is this one. Okay, so it's just rotated the other way around. And same for figure 3, 1, 2, and 3 trapeziums. Okay, so there's a pattern to the number of trapeziums that's related to the figure number. Now we have a table given to us below. So if you look at the table, we have figure number, we have total people, and we have the number of people who are seated at the unshaded triangle. Okay, so let's observe the pattern for total first. So if you notice for total, there is a constant increase. So there is a constant increase of 3. All right, from 5 people plus 3 to get 8. Same for the next one, plus 3 to get 11. So it's simple to fill up this. Just plus another 3 and you get 14 people at figure 4. Now, as for the people who are seated at the unshaded triangles, again, you notice there's a pattern here. All right, so 4, 6, 8, there is a constant increase of 2 people plus 2. Same for here to here, plus 2. And of course, goes the same for the next row, plus 2. Okay, so that's it for part A. Now for B, find the least number of trapezium-shaped tables Anna needs if she's planning to seat 21 people around the table. Okay, so for 21 people, it will be the total people that she wants to seat. All right, so we should be looking at this second column. So you can ignore this for now, look at the second column. So starting from 5 people at the first figure, I need a total increase until I can seat 21 people. Okay, so we're going to first find out the total increase first. From 5 people, how do I increase the number of people to 21? So that's where we do 21 minus 5. So I need a total increase of 16 people. Okay, now when you have a constant increase like this, what you're going to use is intervals concept. All right, so every one interval is every one increase. All right, so in other words, the difference between a figure number and the next one is that one interval. So every one interval is 3 people. All right, but because there's a total increase of 16 people, okay, so I'm going to just draw a very huge arrow. That means there's a total increase of 16 people. But within this plus 16, there is many plus 3, multiple sets of plus 3. So in other words, we need to find out how many intervals are within this plus 16 to reach 21 people at some figure number which I don't know at this point. Okay, so since there will be many plus 3s within the plus 16, to find out how many of those are there, I have to do a division. 16 divided by 3. Now, but of course, we all know that 16 is not in the 3 times table. Hence, you should end up with a remainder for this question, for this solution. All right, so 16 divided by 3, that will give us 5. Okay, so what is the remainder? So when you key in calculator for this, right, it will give you like a really long repeating decimal. Okay, so please do not put down the decimal because intervals you can't have like 5.5 interval. All right, so you gotta calculate out what's the remainder. So to do that, you do the opposite of division, 5 times 3, because forward is divide, so backward 5 times 3. 5 times 3, that will be 15, right? And then you take 16 minus 15, that will be a remainder of 1. Okay, and this remainder will be referring to remainder of 1 person. Because 16 is the number of people, the increase in people. So this is the remainder. The remainder also refers to people as well, which is a person. Okay, now from here, we are going to figure out what is the figure number that I can arrive at after I move 5 intervals downwards. Okay, so if you notice the pattern is from figure 1, when I move 1 interval down, I reach figure 2. When I move 2 intervals down, I reach figure 3. When I move 3 intervals down, I reach figure 4. So if I were to move down 5 intervals, all right, simply the figure number that I will arrive is 5 plus 1. So notice the pattern is the intervals plus 1 to give you the figure number that you should arrive at. All right. Now, the moment we figure out is figure number 6. If you look at the question, we are interested in the number of trapezium-shaped tables. So if you recall just now at the beginning of our discussion, I did highlight that figure number is the same as the number of trapeziums. Figure 1, there's 1 trapezium. Figure 2, there were 2 trapeziums. Figure 3, there were 3 trapeziums. So if I'm at figure 6, that would also mean 6 trapeziums. Okay? Now, be careful. Do not stop here. Why? Because you may need to think about whether this one person requires another trapezium or not. All right, so don't forget, whenever you have a remainder, do give some thoughts to whether the remainder is it important. Must that be included? Okay, so this 6 trapezium, can it fit another one person in? All right, so what I know is from my division, this remainder will not be able to squeeze into the 6 trapezium shaped tables. All right, it's just strictly 6 trapeziums, which means that if I would like to fit another one more person in, I would then need to bring in another trapezium table. Even though bringing in another trapezium table may mean that I can seat more than that one person. Maybe I can seat more than this one. I can fit another 2 people. I can fit another 3 people. But honestly, it doesn't matter. I just want to make sure that the number of tables can comfortably sit all 21 people. Okay, so that means to have one more trapezium, my total trapezium tables is 6 plus another 1 trapezium. So that's 7 tables. Now let's go on to part C. Find the maximum number of people who could sit around the tables if she plans to have 24 people sitting at the unshaded triangles of her tables. So this time the 24 people, we are interested in those seated at the unshaded triangles, which means that on my table here, I should be looking at this column. So again, can we use intervals concept? Definitely, okay, because luckily for this, it's a constant increase again. All right, so when you have a constant increase, it's safe for you to use the intervals concept. So you want a final figure number to have 24 people. So in other words, dot, 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 okay, I should have 24 people here. So you have to first find out what is the total increase first, like what we did earlier on. Okay, so to find this total increase, I have to use 24 minus the 4 people at the start. So now I know that, okay, this is a plus 20. It's an increase of 20 people starting from the first figure number. Now, but within this increase of 20, we know that there are many increments of 2. Okay, so don't forget, okay, within this plus 20, we are actually increasing slowly, figure to the next figure to the next figure. So it will be plus 2, plus 2, plus 2 gradually until everything, all the plus 2s adds up to plus 20. So with these two information, I can find the number of intervals. So the number of intervals, in other words, is also the number of plus 2s. Okay, so simply 20 divided by 2. So that will be 10 of such plus 2s moving downwards. In other words, also 10 intervals that I should move down. All right. Now, with this number of intervals, again, I would like to be interested in the figure number that I would arrive at. All right. So starting from figure 1, you are moving down 10 intervals, which means you arrived at figure 11, 10 plus 1. Okay, like I said just now, the figure number that you arrive at is, if you notice, the pattern is 1 more than the number of intervals. Now, once I reach figure 11, all right, then if you look at the question again, we want the number of people who could sit around the trapezium-shaped tables. So what this question is asking is they want the total number of people who could sit around the tables, which is this total people. Okay, so therefore, to focus on this, you might want to see if there's a link or a connection or a relationship between these two columns. All right, so if you notice between these two columns, right, there is a pattern. So this is 4 and 5. This is 6 and 8. This is 8 and 11. Do you notice the increase, or sorry, I rather say the decrease, all right, from 5 to 4, 8 to 6. You notice there's a decrease of 1, decrease of 2, decrease of 3, decrease of 4. Okay, so the opposite way is an increase lah. So this is 4 plus 1 give you 5, 6 plus 2 give you 8, this one plus 3, this one plus 4. So notice that the plus something here will tally with the figure number. Figure 1, this is a plus 1. Figure 2, this is a plus 2. Figure 3, this is a plus 3. What about at figure 11? All right, so just now previously we already know we have 24. We need to have 24 people sitting at unshaded triangles. All right, but because I'm at figure 11, when I have 24 people at unshaded triangles, okay, so yes, total people in this case, unshaded triangles plus the figure number, in other words. So total people seated at figure 11 would be 24 plus 11. Okay, so that means you know that this figure 11, this has to be plus 11 to get the question mark here. All right, and that will be 35 people.